Hello, welcome back again. Today let's look at the second order differential equations. We have got two forms of second order differential equations. First, you need to know how to identify this. This is second order differential equation. You look at the highest degree, you have got the highest power here is 2, so it means that this is a second order differential equation. You have got second order differential equation of this side and this side. If this side is equal to 0 like the first one, we call this one is homogeneous. This is now homogeneous differential equation. But if this side is equal to another function of x and y, this is now non-homogeneous. So today we want to deal with what we call the homogeneous differential equation like the first one. That is a d squared of y over dx squared plus b dy over dx plus cy is equal to 0. This is a differential equation. So we can let dy over dx to be equal to d. So if we replace, if this one is equal to this one, then it therefore means that d squared over dx squared shall be equal to d squared. So let's replace dx and dx squared in this equation using d. We shall form a d squared plus bd plus cy, maintaining the y's, to be equal to 0. That one is equal to 0. But we know that such equations have got a general solution of the form y is equal to a exponential of mx. Y is equal to a exponential of mx. So if this is y, what will be dy over dx? dy over dx shall be, if you differentiate this equation with respect to x, it shall be m a exponential of mx. And d squared y over dx squared shall be m squared a exponential of mx. So if you have all these parameters, we can replace them in this equation, in the d equation, and obtain, we shall have a into d squared, that shall be m squared a exponential of mx plus the b becomes b m a exponential of mx plus y, that is a exponential of mx, to be equal to 0. Are we together in that? So if we can factor out the common terms, that is a exponential of mx is common, we shall have am squared plus, here we shall have bm, here is, what do we get here? Plus 1 to be equal to 0. Are you together in that? So what we form inside here is what we call an, what we form inside is called an auxiliary equation. This one is called auxiliary equation. Auxiliary equation. So here we have got C. We have neglected C. Auxiliary equation. So this auxiliary equation, we know that when a is not equal to 0, it therefore implies that a exponential of mx is therefore not equal to 0. It therefore implies that it is the only auxiliary equation, the am squared plus bm plus c is equal to 0. So we can solve for m in the quadratic equation. In the quadratic equation. So, and we also need to know that this method of solving second order or differential equations using the d method, this one method is called the d operator. D operator method. So considering this quadratic equation, we can have three possible answers, sorry. We can have, the first answer is 2. We can have two different real roots. Two different real roots. That one can be alpha and beta. Consider that m is equal to alpha or m is equal to beta. Two different real roots. Number two, we can have, if that function has got two equal real roots. Real roots. That is when m is now equal to alpha. Or we can have, and this one mostly happens when b is equal to 4ac. This case happens when b is greater than 4ac. And the third one, we can have two complex roots. Two complex roots. Two complex roots happens like m shall be equal to alpha plus or minus beta in a complex conjugate. This case happens when b is less than 4ac. When we get the root of a negative number, is when we get such cases. And when all those cases apply, when we get if m is equal to alpha or beta, the solution of y comes in the form of a exponential of alpha x plus b exponential of beta x. But that is the first case. In second case, when two equal roots, when the two equal roots are obtained, this is when two different roots. When we get this one, two different real roots. But for two equal roots, when m is equal to alpha, we get y is equal to ax plus b exponential of alpha x. That's it. Case 3, when we have got two complex roots, we have y is equal to, this case is very, very interesting. Y shall be equal to something little bit different. That is exponential of alpha x, where alpha is the real part of the complex roots, into a cosine of alpha x plus b sine of, here is beta x, here is also beta x. That one we have in that form. So after knowing all that background information, we can have one example to do if we get the value of m. Is it complex? Is it what? Then we see how to get the exact solution. So let's do this example as our first example. Given that d2 dy squared, d squared y over dx squared plus 5 dy over dx minus 3y is equal to 0. Given the boundary that x is equal to 0 when y is equal to 4 and dy over dx is equal to 9. So we are told to find the general and the particular solution. Find the general and the particular solution. So the first step, you let d over dx to be equal to d for you to be able to form the d operator equation. So we shall have 2d squared plus 5d minus 3 everything into y is equal to 0. So this one is where we form our auxiliary equations. That is, you can replace d with m. Now you have 2m squared plus 5m minus 3 is equal to 0. Then we solve for m. So using quadratic formula, we have m is equal to minus 5 plus or minus the square root of 5 squared minus 4 into a is 2 and c is negative 3. Everything divided by 2a, which is 2 by 2. That's an shall give us form. So this one shall be minus 5 plus or minus the root of 5 squared is 25 minus this times this times this, 4 by 2 by negative 3, that one shall give us negative 18. Is it so? This by this is 8. 8 by 3, let's read. 4 by 2 is 8. 8 by negative 3, that is negative 24. Making it positive. Everything divided by this, that is 4. So the content of the bracket is 49. The root of 49 is 7. So we have got 5 plus or minus 7 over 4. So m shall be equal to, when here is plus, here will be 2, m is equal to half. Or when here is minus, that one will be minus 12 over 3, m shall be equal to negative 3. So we have got two roots of m which are distinct and real. Distinct and real. Two real roots. So when the two roots are distinct and real, we, from our analogy, that is rule number 1, when both are real, we have got y in this form. So when the two roots are real, so y is equal to a exponential of alpha x plus b exponential of beta x. So we know our alpha and beta, so we have that our y is equal to a exponential of our alpha is now a half of x plus b exponential of negative 3x, which is our beta. So this one is our general solution. General solution. So we can impose the boundaries for us to get the particular solution. How do we impose the boundaries? We say, we are told that y is equal to 4 when x is equal to 0. So y, which is equal to 4, that is 4, shall be equal to a exponential of 0 times half, that one shall be 0, plus b exponential of negative 3 times 0 will be still 0. So we get that 4 is equal to, any exponential of 0 is 1. So this one forms a linear equation that 4 is equal to a plus b. So this one forms our first equation. Then we know that y is equal to this one. So we can find dy over dx. So if y is equal to a exponential of a half x plus b exponential of negative 3x. Let's get dy over dx by differentiating in this equation with respect to x. If you differentiate an exponent, the coefficient of the variable comes beneath. That one shall be a half a exponential of a half x plus, so this negative 3 precedes, it becomes negative 3b exponential of negative 3x. That one is your dy dx. And we know that dy dx is equal to 9 when x is equal to 0. So you replace here with the 9 is equal to a half a exponential of 0 minus 3b exponential of 0. Still, exponential of 0 is 1. So we get that 9 is equal to a half a minus 3b. So this one is our second equation. So we can solve for both a and b in that equation. We can solve for a and b in that equation. You can solve for a and b in that equation in this format. So you bring the first equation as 4 is equal to a plus b, and then 9 is equal to a half a minus 3b. You can make a the subject of the first equation as a is equal to 4 minus b. Check this one, replace in the second equation, you get that 9 is equal to a half into 4 minus b minus 3b. Expanding on the brackets, you get that is 2 minus b over 2 minus 3b is equal to 9. So if you combine this, you get, take this one the other side, it will be negative. You get 7 is equal to a half b minus this one, that one gives you negative 7 over 2b. So b shall be equal to 7 multiplied by negative 2 over 7, giving us b is equal to negative 2. If you get the value of b to be negative 2 as that, We can as well get the value of A. That is A is equal to 4 minus B, that is minus 2, giving us A is equal to 6. So if you have the value of A and B, you can replace in the general solution for you to get the particular solution. The general solution was y is equal to A exponential of a half x plus B exponential of negative 3x. Replace the value of A and B, you get y is equal to A, which is 6 exponential of a half x, plus B, which is, what's the value of B? Negative 2 exponential of negative 3x. So this one is now our particular solution. This is now the particular solution of this second order differential equation. So the basic thing you need to understand, when we have two different rules of the auxiliary equation, which type of format do we have? The general solution. When we have got complex, which type of general solution do we have? So after mastering that, you will be able to solve them. So we shall stop from there. I've posted some examples there and an exercise. Try to do them using this method. If there are any challenge, you post for me and I will give you my feedback. Thank you for now.